industrialization and reach a peak, okay, reach a peak, and after reaching this peak, you have to slowly cut down your emissions. This is what is called as a peaking agreement. What is peaking agreement? Go ahead with your industrialization, go ahead, but after certain limit, you have to come down, cut your emissions. Now, understand this, how it happens in the diplomatic world. In our Bonn conference that happened, India went, and another important point is, this whole 4 agreements which were signed, it was in a forum called as an MEF. Not in a official forum, it was in an unofficial forum called MEF. Now in the Bonn conference, that was the next conference which we went. We went there, and US says, see India, you agreed to 2 degrees centigrade. You also agreed to peaking agreement. So what does this mean? If you work out all the statistics, it means that you have to reach the peaking by 2015. That means in next 10 years, do whatever industrialization you want, and after 10 years, you have to start decreasing. Arey Baba, India says, what is this? This is not fair, right? 2005 years, how much industrialization can I acquire? Not much. And what happened to the MDG goal? That was the 4th goal, right? The 4 agreements were there. One was the targets, one was the MDG, one was your peaking, and one was your 2 degrees centigrade. Now by using these 3, you are asking me to come to the position to a compromise. What happens to your MDG? And where was this treaty signed? It was signed in an unofficial forum. Why are you taking it seriously? So this is how you have to understand. This is how talks happen at the industrial level. I mean at the international level. This is what is called as diplomacy. So, what can you expect in the climate change? You can expect talks on adaptation fund. Even recently the same talks has been happening about adaptation fund. Read any newspaper, this is what happens. A climate adaptation fund. Right? What is happening to the adaptation fund? I have told a detailed story about these things. Then it's the individual versus per capita, the EU story, the AOCs versus OECD versus your developing countries. Then it's the Kyoto Protocol, understanding the Kyoto Protocol, problems of Kyoto Protocol, what the developed countries are saying, what the developing countries are saying, the 3 clauses of Kyoto Protocol which we are opposing. All these things form your climate change. So I hope I have given you a basics on climate change. So you can go ahead. Now you are empowered to read any article on climate change. Now, next, we will speak about the nuclear deal. Recently in your newspapers also, India-France nuclear deal agreement was there. Right? In the nuclear deal, there are 2 things which you have to take care of. One is the nuclear fuels. What are the different types of nuclear fuels? USA always they get tensed when they say that Iran, we have found plutonium in Iran. Why? What is this plutonium? See, you have to understand the science and technology, how the UPSC asks the questions. The questions is not. You don't have to have the complete this one. You have to understand the. You need to have a deep knowledge. I'm not telling you don't have to have deep knowledge. You need to have a knowledge, but you need to have a knowledge from the policy perspective. You don't have to go to the atomic level and understand too much of science into it. No. That's not the necessity. The necessity is you need to know from a black box perspective. What is plutonium? What is uranium? What is this? What is that? And this is not so easy. This needs you to have a width of knowledge, a high width of knowledge. Now, nuclear deal. What is this nuclear deal? See, nuclear fuels, there are 3 cycles. We need to understand, before you read about nuclear deal, you need to understand the nuclear fuels. There are 2 types of nuclear fuels. One is the fission fuel, one is the fissionable fuel. Fission fuel means these are available in nature. They undergo fission simultaneously. You put that, you go into fission. Put that, fission. They can easily undergo fission. fuels. No, fission fuels are not available in nature. Why? Because they can easily undergo fission, right? They are not available in nature. But fissionable fuels, for example, thorium is a fissionable fuel. It is available in nature and it will give rise to some fission fuel in the process. That is called as a fissionable fuel. Fission fuel, fissionable fuel. There are 5 important fuels which you have to understand. 1 is the plutonium. 2 is your natural uranium. 3 is your enriched uranium. 4 is your uranium-233 and 5 is your thorium. Please write this down. 5 things: plutonium, natural uranium, enriched uranium, uranium-233, thorium. Plutonium is a very good fuel. This is the best fuel that's available in nature. Why? Because 1 kg of plutonium will give you more energy compared to any other fuel. And also it gives very less waste. Whatever the waste it comes, right, it's not so poisonous. That's a xenon. It has a very low output of xenon. And another important thing is, it's called as a high breeder ratio. What do we mean by breeder? That means if you have a plutonium core and if I put a natural uranium, which is not so good fuel, then natural uranium will get converted to plutonium, which is a good fuel. That's called as breeder ratio. That means the amount of plutonium this plutonium generates back through the natural uranium is higher compared to any other fuel. So that is called as a breeding ratio. So that's why plutonium is the best fuel. That's the best fuel. And another important thing which you have to note is that plutonium undergoes fission by a slow moving neutron, also a fast moving neutron. See, when we study these reactors, you need to understand which are the fuels which undergoes fission by a slow moving neutron. When bombarded with a slow moving neutron, some fuels undergo fission. And when bombarded with a fast moving neutron, some other fuels undergo fission. There is only this enriched uranium which requires a slow moving neutron. Plutonium undergoes both slow and fast. Natural uranium, fast moving neutron. Enriched uranium requires a slow moving neutron. Uranium-233, fast moving neutron. Thorium, it doesn't undergo fission. It gives to uranium-233. Okay, it has a capability to get converted to uranium-233. Now, this is the important thing which you have to understand. Plutonium is the best fuel. Natural uranium. Natural uranium is not such a good fuel. Okay, it's not such a good fuel, and it can undergo fission by a fast moving neutron. So, do we need a moderator? No. Moderator, the work of a moderator is to slow down the neutron. But natural uranium, if you use, it requires a fast moving neutron, hence it doesn't require a moderator. But whatever heavy water we use, it acts as a coolant. The work of the heavy water is for a coolant, not as a moderator. Okay? So for natural uranium, for uranium-233, you don't need a moderator. You require a coolant. And our India, all reactors, most of the reactors, not all reactors, most of the reactors, initially in Tarapur we had this thermal reactors which required a slow moving neutron. Whereas other than that, all other reactors are fast reactors. That is, it requires a fast moving neutron. Okay? Then, next is your natural uranium. Understand this, natural uranium, it's not a good fuel. It requires a fast moving neutron. So there is no moderator, it's a coolant which is needed. Then comes your enriched uranium. Enriched uranium means, what do you mean by enriched? Something is present, right? That is called as a proportion of uranium-235. Write this down very well. Natural uranium is uranium-238. What is this? This is uranium-235. Enriched uranium. Amount of uranium, the percentage of uranium-235 determines whether it's enriched or not enriched. For example, we call it as a low enriched uranium if uranium-235 content is 4%. This low enriched uranium is used for all the transport, other purposes. All the purposes of transport, or what India gets from France is a low enriched uranium.